Hello everyone, this is our session 8 on application of derivatives. We are on exercise 2.4. Exercise 2.4, question 14. So let us begin. Yes, so what is, we were doing application of derivatives with word problems. So let us start with question 14. Okay, so it says, find the largest size of a rectangle that can be inscribed in a semicircle. Okay. That can be inscribed in a semicircle of radius 1 unit. Okay. So that two vertices lie on the diameter. So that two vertices lie on the diameter. Okay. So first of all, we have to visualize a diagram of this problem. So let us first draw a diagram that represents the question. Find the largest size of the rectangle that can be inscribed in a semicircle of radius 1 unit so that two vertices lie on the diameter. Okay, so let us begin with the rectangle. Sorry, we'll have to first draw the semicircle and then inscribe a rectangle in it. So let us do the semicircle first. Yes, and now let us inscribe a rectangle in this. Now roughly our diagram should look according to this, right? So let us take the center here as O. Okay, and A and B as your endpoints of the diameter. Now endpoints of diameter and were two vertices of the rectangle should match. Okay, so here what we have drawn is an approximate figure. Now, when I actually want to get a rectangle which should fit in this semicircle, okay, let us say this is 1 unit, 1 unit. It should be touching the vertices. Okay, now find the largest size of the rectangle. That means you have to find the length and the breadth of this rectangle that can be inscribed in a semicircle of radius 1 unit. So I have put in the radius as 1 unit so that two vertices lie on the diameter. Okay, so basically this is your length, okay, of the rectangle. Now what I'm going to construct here is a small triangle. Please observe. Okay, so can you see this triangle? We will name this triangle as say P over here. So OBP, triangle OBP, this is your radius R. Okay, and this side will be your breadth B. Okay, so we'll take small l for this. Okay, so the small l and B of the rectangle. So what can we say about the triangle OBP? So in triangle OBP, okay, what can we say about it? Can we say that it is a 90-degree triangle? Why? Because P is right angle because of the rectangle, right? So we can say that angle OBP is equal to 90 degrees, correct? Yes. Therefore, we can say R square is equal to L by 2 the whole square, right, plus B square, right? Okay, now what is R square? It is 1, radius of the triangle, okay, and radius of the circle, which is the hypotenuse of the triangle. L by 2 is L square by 4 plus B square, okay. Therefore, we can say that 4 is equal to L square plus 4B square, okay, and therefore we can say that L square is equal to 4 minus 4B square. Therefore, I'm going to get L square as an equation of B square, that is 1 minus B square. Okay, we'll mark this as equation 1 over here. Now, let us go to the derivative part of it. It says find the largest size of the rectangle that can be inscribed in a semicircle. Okay, that means we have to find the area of the rectangle, which should be the largest. If I find the length and breadth of this largest rectangle, I get the maximum area, right? So area of the rectangle is length into breadth. Okay, area is equal to, now what is length square? 4 1 minus B square. So what is only L? It will be 2 root of 1 minus B square, correct, multiplied by B. This is your area. Yes. Now, what do we have to do? Differentiate this with respect to the one length that we have over here, B. So, we'll say dA upon dB. Let's say differentiate first. So, differentiating with respect to B. dA upon dB, okay, is equal to, now 2 is a constant, let it be. This is a multiplication term. So, first term as it is, derivative of the second term, that is 1, okay, plus second term as it is, derivative of the first term, 1 upon 2 root of 1 minus B square into minus 2B. Okay, so what do we get over here? 2 cancels out, plus into minus is minus B square upon root. Okay, so dA upon dB is equal to 2 as it is. Okay, denominator I'm taking common, root of 1 minus B square. So I'm going to multiply this also by 1 root of 1 minus B square. This is what we get, minus B square. Okay. Now what do we get? What do we have to do in the next step? It says that the area should be maximum because you have to find the largest rectangle. Therefore, for area to be maximum, what can we say? For area to be maximum, dA upon dB should be equal to 0. That means 2 bracket 1 minus 2B square upon root of 1 minus B square, correct, is equal to 0. Okay. Now we'll have root of 1 minus B square going there becoming 0. 2 minus 4B square equal to 0. So we'll have 2 equal to 4B square. Okay. Therefore, B square is equal to 2 upon 4. B is equal to plus minus 1 by root 2. Okay. Now see, B is a breadth, so breadth cannot be negative. So now we have breadth as 1 minus 1 upon root 2. So we're taking B equal to 1 upon root 2. Therefore, length is equal to, and what is the length formula that we had derived? L square is 4 1 minus B square. So L will be 2 root of 1 minus B square. Let us substitute value of B. So L is equal to 2 under root of 1 minus 1 by root 2 the whole square. 2 the length will be, let us calculate that. The length is equal to 2 under root of, we're left with 1 minus half, that is half, sorry, yes. So which is 2 upon root 2, rationalize it, length is equal to root 2 units. Okay, so basically, when you want the area to be maximum inside the semicircle, what are the dimensions of the rectangle? So in the end, you just have to write, therefore, the dimensions of the largest rectangle should be, sorry, should be, and then you put in length and breadth. So length equal to root 2 units and breadth equal to 1 by root 2 units. Okay. So if you observe, when we started the problem, I have written, though we know the diameter length as 2 units, okay, I haven't yet given the length value as 2 units. Reason being, we are not sure whether the length would be 2 units for the maximum rectangle, okay, because you can observe it doesn't, if you touch it to the endpoints of the diameter, then what will happen? It will not uh, make a rectangle. It will just touch the semicircle. Okay, so it says that the two vertices should lie on the diameter. It is not said that they should lie on the endpoints, because that is not possible. Okay, that is why what should be the length? So that length we have found out as root 2 and breadth as 1 by root 2. Clear? So this is the value of the dimensions of the rectangle. Clear? This is question 14. Let us move to question 15 now. Let us go to question 15 now. An open cylindrical tank whose base is a circle is to be constructed of a metal sheet so as to contain a volume of pi cubic centimeters of water. Find the dimensions so that the sheet required is minimum. So let us say that a rectangular sheet is required to make this cylinder. Okay. So if we have a rectangular sheet that is to be folded into a, let us say, into a cylinder. So how would we do this? So you can say that length has turned into the circumference of the cylinder and breadth has turned as the height of the cylinder. Okay, so what is the volume of a cylinder? Base area. Okay, so volume of cylinder, right, is equal to pi r square is the base area multiplied by height, correct? Now it says that this same cylinder contains pi cube of water, so which we'll say equal to volume of water, right? So what we can get from here, therefore we can say pi r square h is equal to pi a cube. Okay, so we have h is equal to a cube upon r square. Okay, we'll mark this as equation 1. Now the next step is to know that what area of the sheet will I require, or what minimum area of the sheet will I require. So what is the area of the sheet given by, one second, sorry, area of sheet. In terms of the cylindrical area, it will be area, or we can say total surface area of the cylinder. What is total surface area of cylinder now? Total surface area of cylinder. So it is base area, that is 2 pi r h. Sorry, not base area. 2 pi r h is your circular area, that is curved surface area. Okay, curved surface area plus your base area, that is pi r square. This is your total surface area. Now this area of sheet will be same as total surface area of cylinder. Now we have two variables here, so let us substitute this one h that we have over here in terms of r. So that is from equation 1, a cube by r square. So we have 2 pi r a cube by r square plus pi r square, okay, which is equal to, let us have r cancels out here. We have pi common, okay, and then we have 2a cube by r plus r square in our bracket. Is that correct? Yes, a cube by r plus r square in the, sorry, not 2 is not common, so this will come off. Yes, pi common and 2a cube upon r plus r square is left in the area. Now, to get this as the minimum, the differential or the derivative of this should be 0. So let us differentiate this with respect to r. So differentiating with respect to radius r, okay, area is equal to or dA by dr is equal to, let us differentiate this. So we have pi outside, we keep it here. 2a cube is a constant, we'll keep it separate. We have 1 upon r, which will be minus 1 upon r square, okay, and we have plus r square, that is plus 2r, okay. For area to be minimum, what will we say for area to be minimum? dA by dr should be 0. Okay, so we'll equate this as pi 2a cube minus 1 upon r square plus 2r equal to 0. Okay, so we are going to get 2a cube minus 1 upon r square equal to minus 2r. 2 cancels out. Okay, minus becomes plus. Then we have a cube is equal to r cube. Taking cube roots, we have a equal to r. Okay, we have r equal to a. This is one dimension, and how do we find out h? So from equation 1, h is equal to, what is the formula for h that we had from equation 1? A cube upon r square. So let us put this a cube upon r square, okay, so which is equal to a cube upon, what is value of r? A, so a square. So therefore h is equal to a. So what are the dimensions of the cylinder that we are getting? R is equal to a and h is also equal to a. This is the dimension of the sheet also. Is it correct? What is length of the sheet? Length will be, length of sheet is equal to, let's go to the diagram. What is length of the sheet equal to? It becomes the circumference, right? So 2 pi r, right? So which is 2 pi, and what is the value of r? That is a. And what is your breadth of the sheet? Is breadth of sheet, you can say. What is the breadth of the sheet equal to? It is equal to the height, so which is equal to a. Either you write it in terms of the cylindrical diameters or dimensions, or you can write it in the terms of the rectangle dimensions. Any two would do. So this is the value of the radius and the height of the cylinder that you require. Clear? This is question 15. Okay, let us move to question 16 now. The perimeter of the triangle is 10 centimeters. One of its sides is 4 centimeters. What are the other two sides of the triangle for its maximum area? Okay, so first of all, what formula of the area will we use? That is one question. Okay, And secondly, how do we find out or how do we keep only one variable in our question? So what we can say is, since perimeter is given, we are going to use the formula of perimeter only. That is the one which includes the perimeter. So area of triangle, first of all, okay. In terms of perimeter, what do we know? S under root of S minus A, S minus B, and S minus C. What is A, B, and C now? Let us see that. Okay, so first let us make a triangle here. Okay. Yes. So we'll name these sides as A, B, and C. S is equal to semi-perimeter of this triangle. So A plus B plus C upon 2. We know that perimeter A plus B plus C is 10 of this triangle. So 10 upon 2 is 5. So we know that S is equal to 5 centimeters. Okay. Now area of this triangle can be written as 5 bracket S minus A, that is 5 minus A, S minus B, that is 5 minus B, and S minus C, that is 5 minus C. Clear? Now what can we say about A? So it says one of its side is 4 centimeters. So I can write it as 5 under root of 5 minus 4, one side. I don't know the other two sides, so we'll leave it as it is for now. Okay. Now, what can we say about B and C? If one of it is 4, its perimeter is 10, that means what can I tell about B and C? I can say that B plus C, or we can say perimeter is equal to A plus B plus C. So 10 is equal to 4 plus B plus C, right? Therefore, B plus C is equal to 6, correct? And so we can say, therefore, B is equal to 6 minus C. This B value we are going to use in the area formula now. So we'll call this area as 1 and this as 2. Okay. Yes, so this is area equal to, and this is 1. What we can say now is substituting 2 in equation 1. So we'll say substituting equation 2 in equation 1. So we have area is equal to 5 under root of 5 minus 4 is 1. 5 minus, what is B value? 6 minus C. So let us put 6 minus C here. Okay. And 5 minus C. Okay. So we are going to get 5 under root of 5 minus 6 minus C. 4. We'll have, what is 5 minus 6? Minus 1, minus into minus plus C, minus 1 plus C, and 5 minus C over here. So let us multiply the two brackets. We'll have minus 5 plus C plus 5C minus C square. Okay. So we have 5 under root of minus 5 plus C plus 5C is minus C square plus 6C minus 5. Okay, so what we can do is we'll square this area as A square. So we get 25 bracket minus C square plus 6C minus 5. Okay. Now, why am I squaring it? Because it's a root term, derivative would be a little more longer term. So you might make a mistake there. So we're taking that as the value for derivative. So we say A square is equal to 25 minus C square plus 6C minus 5. Okay, differentiating with respect to C. Now, why are we differentiating this? Because we want to know the sides of the triangle such that we have maximum area. So first we'll differentiate, and then we can say that equated to 0 for maximum area. So 2a dA by dC is equal to 25 as it is, okay, minus 2c plus 6 and 0. Okay, so we have this as our differentiation. So dA by dC is equal to 25 upon 2a, okay, bracket minus 2c plus 6. For area to be maximum, what do we have to do? dA by dC should be equated to 0. So we'll say dA by dC is equal to 0. So we have 25 upon 2 a minus 2c plus 6 equal to 0. Okay, so we have minus 2c plus 6 equal to 0, minus 2c equal to minus 6, c is equal to 3. Also, b plus c is equal to 6, therefore b is equal to 6 minus c, b is equal to 3. So what should be the dimensions of the triangle? Therefore, dimensions of triangle should be, one they have already given to you, so it should be a equal to 4 that they have given us, right? B equal to 3 centimeters we found out, and C equal to 3 centimeters for the area to be maximum. Clear? This is the question number 16 that we just solved. Clear? Okay, let us go to question 17 now. Yes, let us begin with question 17. A box with a square base is to have an open top. The surface area of the box is 192 centimeters square. What should be its dimensions such that its volume is the largest? Okay, now let us build a square top box first. So if we have a square base, so square base means square top as well, right? What could be, say that the sides could be rectangular in this case, but the top as well as the base would be square. So let's join them. Yeah. So this is your box. Now it almost looks like a cubical box, but you cannot take it as a cubical box since it's not mentioned. So what we'll do is, since we know that the base is square, so let us take the base length same, okay, and just give the third dimension as height. That means L, B, and H would be for a rectangular box. So now we have L, L, and H. So let us start with what would be the base area first. So base area is equal to L square, right? And what would be the area of each of the vertical sides? So 4 vertical sides, okay, is equal to 4 into, what is the side, what is the dimension of the vertical side? L into H. So 4 L H, correct? That would be your 4 vertical sides. Does it have a top? No, it does not have a top. It is open. So this becomes the total surface area of the box. So total surface area, okay, of the box is equal to L square plus 4LH. Okay, so this we found out from the information that they have given us. One more thing is given is the surface area of the box is given, the value that is 192 centimeters square. So instead of this, we can say 192 is equal to L square plus 4LH. Okay, let us mark this as equation 1. Right? This is your value of surface area. Now, what should be its dimensions such that its volume is the largest? Now, what will be the volume of this box? So we can say volume is equal to of box I'm writing. I'm not writing square or rectangle here. We can say from the basic formula of volume, we can say base area, right, multiplied by height, which is L square into H. Okay. Now let us look at the equation that we already have. Can we write an equation for L square from this? Yes. So what it will be, L square is equal to 192 minus 4LH. Okay. Sorry. Yeah. So L square can be substituted from equation 1. So we'll say over here from equation 1, right, volume is equal to L square value will be 192 minus 4LH into H. Okay. Okay. Now from equation 1, we'll find out an equation for H. So we'll just copy that equation here first. Okay. So we'll say 192 is equal to, we have L square plus 4LH, right? So can I find out H now? So it's be 192 minus L square upon 4L equal to H. Okay. This I'm putting it as equation 2 here and equation 3 here. And I'll say substituting equation 3 in equation 2. Okay. So we can say volume is equal to L square H, which is equal to L square multiplied by 192 minus L square upon 4L. Okay. So L cancels out. We are left with 192 upon 4 into L minus L cube upon 4. Okay, so I'm just taking 1 by 4 outside, and now we'll differentiate the term that is inside. Okay, we'll differentiate it with respect to L. Why do we have to differentiate? Because we want the largest volume, right? So we'll say differentiating with respect to L. So dV by dL is equal to 1 upon 4 as it is a constant, 192 minus 3L square. Okay, so we've differentiated this. For volume to be maximum, what will we have to say? Sorry. For volume to be maximum, dV by dL is equal to 0. Okay, so we have 1 upon 4 bracket 192 minus 3L square equal to 0. Therefore, 192 minus 3L square equal to 0. 192 is equal to 3L square. L square is equal to 192 by 3. So we get L square equal to 318 and 4L is equal to 8 centimeters. So we have L here, and from this L, what have they asked us to find out? So question, what should be its dimensions? So we have to find H also. So H can be written as, you know, an equation for H. So from equation 3, H is equal to 192 minus L square upon 4L. Okay, so we have H equal to 192 minus 4 into 64. Okay, divide by 4 into 8. So H is equal to 192 minus 'sorry, there's no 4L square, it's only L square here. So 192 minus 64, that is 8. 128 upon 4 into 8. So 1s are 4, 3s are. So H is equal to 4 centimeters. These should be the dimensions of the box for the volume to be maximum. Clear? So this was question 17 from exercise 2.4. Okay. Okay. In the next session, we complete this exercise and then we will move on to the next chapter. I'm leaving the miscellaneous up to you. When you solve it, if you have any doubts, you can ask me for the same. Okay. Thank you so much.